Okay, so here we have a friction question with an incline. So I've got my incline here. It's 65 degrees to the horizontal. I've got my coefficient of friction, and I want to calculate the resultant force down the plane. So resultant force down the plane, I'm looking in my I direction here. So set up your axes. My normal force I put in the positive J direction, and then my friction I've got happening up the plane. So it's trying to stop the object from going down the plane. So that's why I put it in that direction. So you can think about the friction's trying to stop the particle from moving. And then I've got my weight force coming down here, which has an I and J component. I've got my mass of 30 kilos. And let's look at our components. So here I've got my normal force. It only acts in the J direction, so I called that YJ. And my friction, I've got a coefficient for mu. So the formula for friction is mu times my normal force, or Zi, because it's in the I direction, positive I direction. And then my W is in my INJ direction. So again here, it's in my negative I direction with my M times G, cos 25, that angle in there, 65 plus 25 gives me 90, and then I've got alternate angles there, which gets me 25. In my J direction, it's negative, that's why I've got a negative here, and then I use sine of 25 with my mg, of course. Now, because it's resting on the plane, it doesn't mean it's jumping up and down, so it means that my J components, if I add those up, that they're going to equal 0. So I'm going to equate those J components. So here I've got a J component, and here I've got a J component. So y plus negative 30 times 9.8 sine of 25 equals 0. Rearrange, and you get 124.25. So the force of my normal is 124.25 newtons. Now I can find my friction, because now I've got my normal force, times that by my 0.4, and I get 49.7 newtons. My resultant force down the plane, now it doesn't say that it's not moving, so would it actually be moving? If I equate and look at the I components, so my frictional force is 49.7 newtons going this way in the positive I direction, but then in the negative I direction, so pulling this way in relation to my weight, I actually have 30 times 9.8 cos of 25, and that's 266.454. So it's got more force pulling in that direction down here. So you could say that the particle would be moving down the plane because it's greater than the frictional force. So it's not at equilibrium. And I want the resultant force. So the resultant force down the plane, I'm just looking at in my I direction. So I add my resultant forces here. So my 49.7 plus my negative 30 times 9.8 cos of 25. So adding the two I's, and I get a resultant force, it's pulling down the plane, of 216.75 newtons.